Hey, this is Steven from LegitTechTutorials, and welcome back to my product design series. So we are back looking at the filament maker, or the multi-shooter expansion modules, the dimensional control, and the automatic spooler module. So the reason why I've been off is I've been working on a second Kickstarter, and that you'll see that in some videos. I did that entirely in videos, and it's for a industrial grade mini shredder, and that is currently up on Kickstarter as of right now. And you guys, wait 1 second. And you guys will see those videos coming soon of me designing that from start to scratch all the way up to the Kickstarter, and maybe even a little bit of manufacturing it. That being said, this guy had to take a step back for a little bit, and also I needed to analyze a few things. Number one, I started analyzing the FSR for the this guy, the FSR that goes and attaches to this thing. And I've done a few things here, and I'll explain what I did in a second. So the FSR that goes down there, and the main issue with the FSR is it's really not very accurate at all. So, and also you would have to get the resistance exactly right. Instead of a 10K pull down resistor, you have to go with something else that gets to that specific setup perfectly. That being one thing, and this particular setup is not really the best for that. So, and also they're kind of expensive, $7, right? And they're kind of so $7, not very accurate, kind of fragile, hard, sort of hard to, not really that hard. They're not really that hard to work with. I mean, there's pretty much very few things you can get wrong with the thing. You just plug them in, they work. So I was thinking about doing one of two things. Number one was I was thinking of deleting this entire thing altogether. So instead of using this, just have like a bar here, a bar straight across, because I want to try to, no matter what, I'm going to be getting rid of this 45. This 45 is nice, but it causes overhang right here. So I'm either going to get rid of the 45 here, and then just have a rigid bar that goes across. And then that holds, not even a spring loaded, just the rigid this piece to the pulley. Just have that rigid right there, no sort of measurement. And then the idea was that when I use the software, what the software will do is it actually won't really modulate the speed of the motor, of the spooler motor. What it will do is it will modulate the speed of the it'll modulate the speed. It won't modulate the speed. It'll modulate the temperature of extrusion. So if it is too small, it will lower the temperature of extrusion. And if it's too big, it'll raise the temperature of extrusion. Because with that, the change will be a little bit buffered, and the change of the chance of it, having a, breaking the filament. Because the worst case scenario when you're doing this is that you stretch the filament and it breaks. Because once you do that, the filament's useless unless unless the user goes in and kind of welds it back. So I was thinking of that to where I could cut this sensor out completely and just have a rigid, because I need the pulley there. I can't get around getting rid of the pulley, so I need the pulley there, but getting rid of a sensor there. The second idea is I'm going to go changing from an FSR to a load sensor. And this is what a load sensor looks like if you guys have never seen one before. This here is a load sensor, and what it has four wires that are attached to multiple strain gauges, and it's on this piece of aluminum stock with holes cut in it. And what happens is you bolt these two sides to your piece, and then you bolt these two sides to your coupler or whatever. I mean, not to your coupler, to your pulley or whatever. Right? It cantilevers out over whatever, and then you have this coupled. And then what happens is that when you put a force on this, because of these holes in this cross section, this is a standard cross section. So what will happen is that this piece of aluminum will deform. As you know from all of our stress tests. So this piece of aluminum will deform right here, and then the strain gauges will actually pick up. They'll actually generate a current. A voltage. They'll generate a voltage difference. And you use these sensors called the that's a sensor. You use an amplifier called an HX711 to amplify that to a voltage that's in the 1 to 5 volt range that an Arduino Mega could read. And then from that you could get very accurate and high resolution of weights. So if you put on a 5 gram weight, depending on what the total weight is, you can get it down to 0.1 of a gram within proximity. So if you put 5 grams, let's just say that I put a pound. I put a pound of weight on there, it will get that pound of weight within 10 grams or so. So it's pretty accurate, right? And then again, the whole reason for doing this is that we're using this so it could talk to the controller and then modulate something to get the filament to the right size. In this case, this one I'm going to be changing both, and then again both of the sensors, the one that's on the dimensional control module and the one that's on the spooler module. And then my other thought is get rid of the one that's on the spooler module altogether. And then these guys run about $5 for the HX711 amp and also this aluminum guy. And I would probably get the 1 kilogram version. And I have one right here, and I'm still trying to get it to work with an Arduino. I have something wired up wrong, so one of my junctions is messed up where I attached a jumper pin to this or something. I attached it wrong. So I'm going to figure out what's wrong with it, and then we're going to run with that. But from what I've seen, when they're working correctly, they are very accurate. And also lower in cost, right? But they do use 2 pins. They use 2 digital pins or 2 analog pins in order to get these to work. You have one for the DT, or the data out, and then you have one for the SCK. So that would be a total of 2. But what this allows me to do is that this allows me to go in and delete this bridge and just have 2 holes over here where that sensor is supposed to go. So what I'm going to do is I'm going to go in and I'm going to delete this. So I'm either going to have this here or I'm going to have something across. So I don't exactly want to go. What I want to do is I just want to go in here and just delete that, because I might have to go in and build a thing across, but I would still have to do it from this view. So what I'm going to do is I'm just going to delete everything that's on here, because that's not exactly how we're going to do that anymore. So with this guy, let's just say that I did the force sensor, the load sensor would go across here, and then that piece would be rigid. So if anything, if I need to adjust the height, I'll just add little tower things here. So just add these up a little higher. And then this would go here, and then the pulley would be right there. But what I'm thinking now, what I've been thinking is that this guy, I want to get as close to the ground as possible as far as on the spooler module goes, because I want as much distance between the nozzle and the dimensional control module. Because with the dimensional control module, that's where you have all the sizing takes place. And so you don't want the filament to distort when it checks the size of it, because if it smashes it, you're going to have all different types of issues. So you want to give it as much time between the 2 places to cool down. Alright, so let's go ahead and stop sketch. Let's go ahead and edit feature. Let's just have these 2, and I'm just going to say that these are .001 or something. Alright. Oh, we have a few more. So this sketch, I'm going to just straight delete that sketch. And then this thing, I'm just going to straight delete this thing. And then I think that was when I cut the holes. Alright. So that is our very drab looking piece now. So the idea is that with this guy here, this would fit on here, and it would actually almost make it across here. I will have to probably cantilever it out a certain amount, so I might have to put a little piece back over here, so it's not exactly square, so a little piece over here, so that this guy cantilevers right out into the center. And another thing also is that this guy, I'm going to have a separate piece that goes across here that does the spooling. So another piece that goes across here that comes up and out of the spooler and goes in here, and then there's going to be a little servo on there that actuates it back and forth. Alright. So that's pretty much it for this here. Give me 1 second. I'll be right back. We'll make that out. Alright, so yeah, that's pretty much it for this model for right now. It's very streamlined now. I'm not going to have any issues with any overhang, so everything looks good. Now the next piece that we're going to look at is the, thought I opened it, I guess I didn't. Spooler module, dimensional control module, is this guy. Okay, so this guy, again, we're going to be getting rid of the FSR. This is the main one that we're worried about, getting rid of the FSR. So, we're going to have to do a few things on this guy to get the FSR. And what I'm going to have to look at is we're going to have to get rid of this. So yeah, we're going to have to get rid of all this stuff. So get rid of all this stuff. Oh, wait, hold on. There we go. Okay. Okay, so we are going to use, actually I didn't really want to delete that. Okay, so this is what we want. I'm just going to draw a circle here for right now, just so I know which one it is. I could rename it, but I don't want to for right now. So let's just have that like that. Which one is that? Sketch number 3. So let me just highlight that so I know which one that is. Okay, so what we need to do is we need to have, we're going to keep this how it is. So we're going to need a hole here that allows our load cell to go through, and then again it's going to attach here, so we might need to kick this out because the load cell's got some height to it. And another thing we're going to have to do is we're going to have to add some extra height there because the load cell has to have okay, so yeah, the load cell has to have some room to flex. So we're going to need to add a little plateau here, right there in the center. So what I'm going to do is I'm going to take a look at this one here. I'm going to grab my calipers. So this guy, it might be the one I used, probably not. So I'm going to grab. Well, I have my. These are my dial. I don't know where my other ones are. I'll have to find those. Okay, so the total length of this guy should be 7 something. Oh, well, not 7. So it's approximately 3 inches. So it's 3 inches long. So I need to make sure that I'm in this sketch. Okay, and then I want 3 inches from this point. Whoa. That's fine. I mean, I could have it over there. That's not a big deal. Except for, yeah, it's gonna have to. So what I'm gonna have to do, let's just make this longer for right now. Where's this length? So let's make this like, ooh, I don't know what that. Let's make this like 150. That's 6 inches. Let's just make this 6 inches. 6 inches. Okay. So now let's look. It should still be okay. Yeah, it didn't really move it much. Okay. So what I'm gonna do is I'm gonna make sure that this moves. Okay, so let's make this 6.5 inches. So now I'm pushing that my printer is only 11 inches, so I gotta be careful. All right, now I have a little bit more space. We'll worry about the roller in a little bit. Okay. All right, so now what I need to do is I need to go here, and what I'll do is I'll just put a pretty big cutout here. So let me go onto this sketch, and then I need to go back over here where we have it extruded it through, and I'm gonna basically put a giant project include. Let's just go ahead and put a square that big, 2-point square. And this square needs to be at least. And then we're going to add a little bit of distance as well. Ooh, it's exactly ground, it's precision ground to 1/2 inch. It's a big square. So let's do like 0.75 inch. Oh, it's too big. Oh, that's fine for now. Okay. And we're going to go where this is extruded. Edit feature. What the hell? I guess it didn't like that. Okay, let's do a square. So again, this only needs to be, what was it, 1/2 inch tall by 1/2 inch. So let's do like 0.6. So I'll do a line from here to like 0.65 inches up. How big is this thing? This thing's small. Oh, it's going to be half of that. 0.325. Let's do 0.3 inch. Yeah, that looks good. Okay. 0.3 inch, and then this is going to be 6 inch, and then this one's going to be 0.6 inch. What the hell? This one I made 6 inch. Yeah, 0.6. Perfect. Okay. Okay. Oh, what the hell? Okay, it did that one, but it didn't do that. Oh, I think it was, I know what it did. What did it do? What are you doing? Okay. 1 second, let me let my cat back in. Okay, 22 minutes. I don't know what the hell this thing's doing. Because it looks fine for me over here. Actually, now that I think about it, it doesn't need to go all the way through this. Why is it not? Oh. I must have just like attached a face there or something. And then, so like I was saying, it doesn't actually need to go... Does it need to go all the way through there? Oh, it does. Ah, that kind of sucks. Because that... You lose a lot of rigidity with that. Okay. So with that, what I'm going to do is start from that point. And I really don't need that circle. Okay. Alright, so let's all the way to that edge. Now what I'm going to do is from that edge... It's a little bit. It's 3.6 inches. Make sure this thing's square. It's not really cut. It's not cut square at the end. It seems like. Yeah, when they cut it, they didn't grind it square. They didn't face it. It's not sitting square in my calipers. Or bent out of shape. One of the two. That might be why it doesn't work. Alright, so what we need is we need to have like a little area that this goes. So where it levitates a little bit. So let's do... And the other issue is that I'm not going to be able to do that not unless these threads could be threaded from the backside. So let's just say that these threads could be threaded from the backside. Okay, so let's do what, like from the back corner, 3/4 of an inch. Okay, so from the back corner, 3/4 of an inch this way, 0.3, 0.75 inch. Okay, so from there to there, we want that, and it needs to be raised 1/2 inch. So rectangle, line. So let's make it 0.25 inch. Okay. Rectangle. And then this is 0.5 inch. And this other one is 0.75 inch. And there we go. So that's going to be the little platform that's extruded. I mean, of course, you don't... Actually, now that I think about it, that's going to... Okay. I'll just leave that there. That's going to cause a lot of issues now that I think about it. So what I'm going to do is I'm going to have it... Wait, what? Am I doing the right one? No. I don't know why it's doing that. Anyways, I want to get rid of I'll show you what I'm going to do. So the issue with that is that it's going to cause a lot of issues with it's going to cause a lot of issues with stuff floating and not wanting to be stationary or whatever. Not on the ground. It's going to be floating. So that's not exactly what I'm looking for. And I don't know if that's all the way to the top. It's not, but it's not letting me. I'll turn off the body. There we go. Why is it doing this? It usually gets rid of everything, and then this face is still there. Okay, there we go. Alright, then we're going to do rectangle, 2-point rectangle, and then this is going to be, what do you say, 0.75 inch, and then this is going to be all the way down to the ground. Okay. So now we don't have any issues with no floating things. Okay. Alright, extrude these two bad boys. Want to make these holes? I think I made these 0.6 inch. Oh, 0.075 inch. What? There we go. Alrighty. So that looks good. So that's where the platform will be established, and then it'll go over here and float to this point, and I don't need to really draw anything. Actually, I could have it cut. I don't even need these two little flanges anymore, because basically this other piece goes over here. I'll keep it on here right now. Reason being is that it will protect you from accidentally hitting it from the back. But this is what, 100 and so it's like 5 inches across. So this is 5 inches across, but what it'll do is when that load sensor is over here in this corner, it'll keep you from hitting that with anything and breaking. I don't know how you're going to break it, but yeah, just keep you from breaking it, I guess. I could probably get rid of it. I'll decide shortly whether I want to keep that thing or not. Alright, so yeah. So probably cut these off. But yeah, this I'll leave off for right now, the holes, because it all depends on which load sensor I'm going to use on it. Again, like I said, same thing for this guy. This guy will have a load sensor here and I'll cantilever out. And from this section, that's a distance of 107.95. So that's 4 inches. Yeah, it's going to be way past that. So 4 inches from there to there. Wait, this is 3 inches. Okay, so it needs to be from here out to the center. It needs to be about 2.5 inches. It's about 2.5 inches. So 2.5 inches from here to here. So what is this distance? So 50. Okay. So yeah, this is almost. Yeah, so this is almost 2.5 inches here. So this is 50. So 50 is 1.96 plus half of this is 25. So that is 12. Wait. Yeah, 12.25. So that is 62. 62. Yeah, so that's about 1.5 inches. About 1.5 inches to the center. So that's actually perfect. This is already set up for this size. So 2.5 inches 2.5 inches to the center where the piece is going to be set up. So this is actually set up. This is ready to go. So all you have to do is change these holes again, and you could delete this. That doesn't have to be there. So let's just edit. Oh, not that one. That one. What the hell is it selecting? Oops. Alright. Yeah, that's fine. So, yeah. So this is with the sensor, and then without the sensor, it'll just be a bar across here with 2 holes in it, or yeah, 1 hole, and then this piece goes down. So, and then this piece that holds on the spool, that holds on the pulley, will go down. So there's a few other things that we need to change. Number one, I printed these pieces. These are too big, so I need to drop the center diameter. And then the next thing I need to do is I need to match this bearing that's going to be used to this bearing on this guy. So I need to put a big ass hole in that pulley. Yeah, so that is the next piece. And that is pretty much it for this video. Alright guys, if you like this video, please subscribe for more videos like it in this series and our series as well. I'll catch you guys in the next video. Thanks for watching. Take it easy.